So it is natural to ask, when will two sets be equal? So what makes two sets equal? So this is what's being defined in this box. We said that two sets are equal if the first set is a subset of the second, and also the second is a subset of the first, okay? So there are basically two proofs that you have to do in order to show that two sets are equal. So we're gonna demonstrate that with example number 2. So it says, let A be the set M where M is equal to 2A, and the set B where B is any integer n where n is equal to 2b minus 2. We want to show that A is equal to B. Okay, so to do that, I'm gonna basically say proof first of all, and I'm gonna start with let A be B sets as defined above. So basically pick the numbers or pick the sets to be how they were described in the original question. Okay, so now I'm gonna do the first step, which is showing that A is a subset of B. Okay, so this is like proof number 1 if you want. Okay, so proof 1. Okay, so in this case, I'm gonna pick an element from A. So let's say M be an element of capital A, and I want to show that it's automatically an element of B. So if I pick an element M from A, then the M will look like 2A, where little a is an element of the integers. But this also means that now M is going to be 2 parentheses A plus 1 minus 1. Okay, so I'm adding and subtracting 1, which means I'm not really doing anything. And you'll see why in a minute I'm doing that. So at this point, I'm just going to basically pretend like A plus 1 is one group altogether, and I'm just going to give it to 2. And then I'm going to pretend like the negative 1 is a group by itself, and I'm going to give it a 2 also. So this will make it 2 times A plus 1 minus 2. Now keep in mind that A was an integer from up here, so that means A plus 1 is still going to be an integer. But 2 times A plus 1 minus 2, that's exactly the form of something inside of the set B. The set B looks like 2 times a number minus a number, minus the number 2. So this means that the element now belongs inside the set B. And so with this, we know now that A is a subset of B. So this is basically the end of the proof number 1, QD1 basically, okay? So that's what we are gonna write. So now proof of number 2, proof of the second A is bigger than B, or in other terms, B is a subset of A. So there's another way of writing this. You can write it like B is a subset of A. So in this case, we're gonna pick an element, let's say n, from the set B, then automatically the n will look like 2b minus 2, where the little b is an element of the integers. And now my goal is to make that number look like something from A. Everything in A looks like 2 times A, so, well, if I take the n and factor the 2 out, I would end up with 2 parentheses b minus 1. But since b was an integer already, then b minus 1 is still going to be an integer. And that's pretty much it. This means that the number that we have looks like 2 times some random integer, which means it belongs in the set A. This proves that B is a subset of A. And that's the end of the proof number 1. So we have the end of proof number 1, we have the end of proof number 2. So finally we can say, since A is a subset of B, and also B is a subset of A, then the A set is equal to B set. And that's the end of the original problem.